Hello again, class. This is going to be chapter 9.5b, which is the surface area of a cone. Now, a cone is related to a cylinder, which we did in 9.5a. It's actually 1/3 of a cylinder having the same size base as a cylinder. Now, in understanding this, we have to go back to the net. Now, we know that the area of the base here is going to be the area of a circle. That's going to be pi r squared. We also know that the cone part itself, the part that you would have your hands around, really isn't going to be a cylinder so much, or a rectangle, so much as it's going to be a shape somewhat like this, a triangle and then kind of a curve to it. The truth is, this bottom part of this curve here is really half of a circle. So we're going to go back to circumference. Now the circumference of a circle is 2 pi r. We only have half of that, so we are going to take 1/2 times 2. That's going to cancel. So we're only going to use the pi times r. Now the lateral area is going to be that pi times r, and then times that slanted height. And notice again, this is where we're using that cursive h, because that will give us this whole area that I just put in blue. Now we also are going to add the area of the circular base, which is pi r squared. So our formula is pi times r times the slant height plus pi r squared. Let's look at an example. In example A, you first of all have to really take a good close look at the base, because sometimes they are going to give you the diameter. 14 meters actually is the diameter, so r is going to equal 7 meters. You will have to be very cautious, careful to look for that. Our surface area is going to be pi times r times the slant height plus the area of the circle, which is going to be pi r squared. Again, we're going to use the radius. You have to be very careful. Sometimes they will give you the radius, so don't just automatically think whatever number I see there on the circle I divide by 2. If they give you the radius, you can just use the radius. So we're going to have 7, and the slant height is going to be 30. Plus pi, and then r squared. Again, you could use 7 squared. I have a tendency to write 7 times 7. Just as when we did surface areas with the cylinder, you're going to leave it first in terms of pi. So this is going to be 210 pi plus 49 pi. In the next step, I will add those two to get 259 pi. Then I will take my calculator and put 259 times the pi key. Notice that we usually will round off to the whole unit, nearest whole unit. So we're going to get 814 meters squared. Probably should write it up here. Usually that's going to be right in your directions that you're going to go to the nearest unit. That means the ones place. Okay, here's example B. You try it. Hit pause. You try it, and then I'll go over how it should be done. All right, our formula is pi r slanted height plus pi r squared. Surface area here is going to be pi. Again, they gave me the diameter, so I'm going to need 4. And my slanted height is 5, plus pi times 4 times 4, or 4 squared. This was going to be 20 pi plus 16 pi. And the surface area if I add those together, is 36 pi. This is where I'll take out the calculator. Multiply 36 times the pi key. Get 113 yards squared. Now, I haven't really talked too much about lateral area. I guess I've assumed that you pretty much realize that if they ask you for surface area and lateral area, you just use that pi r slanted h, give me the 20 pi, and then go to the unit, nearest unit. C is an example of where they're really only going to ask me for the lateral area. And again, they want to go to the nearest unit, which I forgot to write down on any of my notes years ago. Okay? I just want lateral area. The lateral area is going to equal the pi r slanted height. Now this time, yay, they gave me the radius, so I don't have to take it in half. Times 18. So my lateral area is going to be 144 pi. To the nearest unit, that is going to be 452 meters squared. And again, I would caution you too to be a little careful. Sometimes the diagrams aren't going to have meters or centimeters or feet, and then your label would be unit squared. Now remember, we are talking area. Area means we are taking a meter, 8 meters, times 18 meters. That's why we have meters squared. If we're just talking about circumference or a perimeter, that does not have an exponent on the label. And this concludes lesson 9.5b. Scouting out.